Hello, this is Raphael, and today I'll be demonstrating my project, which is the RayTracer with texture support. So when we go ahead and get started and look at the code, so in terms of new additions, first of all, I created a texture class. The texture class has a path for its image, an image of course, a width, a height, a scale in X and a scale in Y, a load function to load the image, and a draw function. So we could just draw that texture to see if the image is loading properly. It also has a constructor, and the constructor calls that load function. Then in terms of the plane, I created this little enum called plane orientation. In our scene, we have two planes, an XZ plane and an XY plane. So that way I can see which is which and distinguish them apart without using something like the normals. Then for the plane, of course, I added that plane orientation and two textures. We have a diffuse texture and a specular texture as well. Then we have these two functions. One runs in the XZ plane and one in the XY plane. That way we can render planes in different orientations. And what other additions are there? I think that's about it. Then if we go to the source code for that, in terms of new additions, we could look at draw function. I added the R key to render, which is something I didn't have before. So you can press the R key if you want to test rendering and you want to hide the window. Yeah, we can go out down here to the render function. So in terms of changes I made here, all it does is goes here into the Lambert shading. So this is not progressive. Yeah, this is regular render. So yeah, here, no shading. Say we have no shading, no Lambert, no Fung. We check the orientation of the plane, and then we calculate the XZ plane to texture coordinate. So what we're doing is we're mapping a XYZ position in the world to a UV coordinate in the texture. Speaking of which, let me show quickly the textures I utilized for this project. So if I go here, planar textures, bin, data, I have a total of 2 textures and then some caustics. So this is water, which is for the bottom of the scene. Then we have these tiles, which are for the wall of the scene, and these set of caustics that are created using whirly noise that I recently learned about and wanted to play a bit with whirly noise, and it's pretty interesting. So yeah, this creates like a moving water effect like that if we loop through the caustics, which I really like. And I'm actually planning on doing an animation with that and uploading. But yeah, that's it for the no shading. Then if we want to Lambert, we do something pretty similar. We check if we're working with a plane, then we check its orientation, calculate um, the correct coordinates in the UV space, in the pixel space of the texture. But in this case, we use the diffuse texture, same as here with no, right? With no Yes, with no Lambert. So here, no Lambert, diffuse texture, Lambert with diffuse texture, and then we do exactly the same thing here, but with Fung shading. So now let me walk you through those functions. So we go down here, we can go to, here we go, XZ and XY plane to texture functions. So all this does is a modulo from the hit position to the texture scale, which is something we define. We're in an infinite plane. So we can define any scale we want, any number of rows and columns, and it will repeat. And we divide that, well, we module that by the texture width and height. So that's what allows the pattern to repeat. A problem is this can go negative. This can go negative because the X or Z position can go negative, and this will return a negative result. So what I'm doing here is adding a texture width and height in order to make that result possible. And same here, the only difference here is here we're working with the XZ plane, and here with a ZY plane. Actually, it shouldn't be called XY plane, it should be called ZY. But oh well. Now let me demo. So I'm gonna go here, close to our shapes, and I'm just gonna use 1-on-1 divisions on the area lights because I want this to run as fast as possible. So let's do a quick render with that. There we go. This is what the scene looks like. We got the plane in the back. We can move around, see what things look like. It has an infinitely repeating pattern, and then we have the water underneath. Now we can turn on the Lambert shading and see what's the difference, which is tremendous actually. So it looks way more realistic with more realistic colors. The light is like over here at 10, 15, and 0. I think it's way up there. Yeah. So to make it look nice, and then we can turn on Fung shading, and Fung shading reveals our specular map and reveals the caustics that I was talking about. So that whirly noise I was mentioning is now getting shown right over here into our shape as a specular map. So this kind of creates the illusion of a water reflection, which looks kind of nice. I'll be animating this and uploading. Yeah, this is my final project. Thank you for everything this semester. This was an amazing project. Had a ton of fun with it, and I hope you liked it. Thank you.